this is 11.2, example 4. 11.2 is operations as radical expressions. In example 4, we're going to simplify radical expressions using FOIL. So obviously, when they are asking us to simplify, we're multiplying these two binomials together. 1, 2 terms, 1, 2 terms. So remember, those are called binomials. And in order to multiply two binomials together, we use the method called FOIL. Remember that FOIL stands for first, outer, inner, and last. So with first, we multiply our first term times our first term. The square root of 6 times the square root of 6. And hopefully you remember from the end of the last video that anytime you multiply a radical times itself, it pops it out of the radical. And the reason for that is the square root of 6 times the square root of 6 is the square root of 36, which is simply 6. So I'm just going to write 6. And then the outer terms, the square root of 6 times the square root of 21. So remember, when you multiply radicals, you just multiply their two numbers together. So we have plus the square root of 126. That's 6 times 21. The square root of 6 times the square root of 21 is the square root of 26. Then we do the inner terms and the last term. So the inside, negative 3 square roots of 21 times the square root of 6. So negative 3. And you keep that number outside the radical because, remember, there's an imaginary number outside of every radical, just like with a variable. So negative 3 times 1, negative 3, and then multiply your radicals together, which we just did a minute ago. So the square root of 21 times the square root of 6 is still the square root of 126. And then finally we have the last terms, negative 3 square roots of 21 times the square root of 21. So here we have another case of where when you multiply two radicals together, they pop out. So I have negative 3 times 21 because the square root of 21 times the square root of 21 is simply 21. So now let's simplify this. I have 6 plus the square root of 126 minus 3 square roots of 126. So that's 1 square root of 126 minus 3 square roots of 126. Notice these are like radicands, so I can subtract them. 1 minus 3. So what happens? Instead of a plus, 1 minus 3 is negative 2 square roots of 126. And then negative 3 times 21 is minus 63. We're not finished, so we can keep simplifying. We can do 6 minus 63, which gives me negative 57. And then what about the square root of 126? Now that's a really big number, so maybe there's something we can do with it. So I have negative 57, that's gone, I did that, 6 minus 63. So I have minus 2 square roots of, now let's try and simplify 126. So 126, I know it's even, therefore it's divisible by 2. So I have 2 times 63. 63 is divisible by, or the factors are 9 and 7. I'm going to leave 9 alone since it's a perfect square and I can take the square root of it and then put times 7. 7 is a prime number, so I also have to leave it alone. So then we end up with negative 57 minus 2 times the square root of 2 times 9 times 7. Well, I can take the square root of 9, and that's 3. So negative 2 times 3, square roots of 2 times 7 is 14. We can simplify further. Negative 57 minus 2 times 3 is 6, square roots of 14. Woo! I know that was a lot of steps. It may have seemed a little confusing. Don't worry, we'll do another one. But I do want to look over this really quick. Now right here, I decided to go ahead and combine these like terms. But you didn't have to combine them right here. You could have found the simplest form of the square root of 126, which we found out was 3 square roots of 14. So you could add 3 square roots of 14 here, minus 3 times 3 square roots of 14. You could have simplified that way, and so maybe we'll do that in the next one to show you what I'm talking about. So let's look at A. 2 square roots of 6 plus 3 square roots of 3 times the square root of 6 minus 5 square roots of 3. Again, we're using FOIL. First, outer, inner, last. So multiply your first term times your first term. 2 square roots of 6 times the square root of 6, so I have 2. Because 2 times 1 is simply 2. The square root of 6 times the square root of 6 is 6. Remember, it pops out of the radical anytime you multiply a radical times itself. So 2 times 1 is 2. The square root of 6 times the square root of 6 is 6. So 2 times 6. because, again, you're multiplying those together. These are being multiplied. 2 times the square root of 6, 1 times the square root of 6. So when you multiply these 2 square roots of 6 times the square root of 6, you get 2 times 6, which I know is 12, and we'll do in a minute. Then you do your outer terms, 2 square roots of 6 times negative 5 square roots of 3. So 2 times negative 5, negative 10. The square root of 6 times the square root of 3 is the square root of 18. Then inner and last. So inside, 3 square roots of 3 times 1 square root of 6. 3 times 1 is 3, so plus 3. The square root of 3 times the square root of 6 is the square root of 18. And then finally, last terms, 3 square roots of 3 times negative 5 square roots of 3. 3 times negative 5, negative 15. Square root of 3 times the square root of 3 pops out. And then we'll simplify. 2 times 6 is 12. And so right here, we can simplify the square root of 18, or we can combine like terms first and then simplify. So I prefer to combine like terms first. It makes it look, that way you have a lot less numbers, a lot less terms to deal with. So negative 10 square roots of 18 plus 3 square roots of 18. Again, they're like terms because these radicands are the same. Negative 10 plus 3, negative 7 square roots of 18. And then negative 15 times 3, negative 45. Okay, we still have some like terms to combine. 12 minus 45, that's negative 36. Then we have negative 7 square roots of 18. So we did 12 minus 45, which is negative 36. Negative 7 square roots of 18. So since 18 is kind of a large number, it's an even number, it probably has something we can pull out. So 18 would be the square root of 9, or the square root of 18 would be the square root of 9 times 2. 9 is a perfect square, therefore I can take the square root of it. So I have negative 36 minus 7, the square root of 9 is 3, so times 3, square roots of 2. Remember that your number is always being multiplied times your radical, so when you pull a number out, you're multiplying. So I have negative 36, negative 7 times 3, minus 21, square root of 2. And since these are not like terms, one has a radical, one doesn't, cannot add them together, and you are finished. Let's look at one more like that one. This is a special one. You might remember the square of a binomial. This is a special binomial, or a multiplication square, whatever, that we learned back in that chapter where we factored in chapter 9. So you may or may not remember the rule for the square of a binomial is a plus b squared is always equal to the first term squared plus 2 times both your terms. So let me get rid of those parentheses. Plus 2 times both your terms plus the last term squared. So you can either use this rule, or you can FOIL this out just like we did here by doing the square root of 7 plus 4 times the square root of 7 plus 4. So you can either FOIL this out like we did on the last two problems we did, or you can use your rule. And I'm going to go ahead and use the rule. So I have the square root, or the first term squared. So the square root of 7 squared plus 2 times both my terms plus 2 times the square root of 7 times 4 plus the last term squared plus 4 squared. So I end up with the square root of 7 squared, the square root of 7 times the square root of 7. Remember, it simply pops out of the radical. The square root and the square, they really just undo each other, so they're gone. So you just have 7 plus 2 times the square root of 7 times 4. Multiply your numbers together, your whole numbers. 2 times 4 is 8. 8 times the square root of 7, so plus 8 square roots of 7 plus 4 squared is 16. And then you just combine like terms. 7 plus 16 is 23 plus 8 square roots of 7. And since these are not like terms, you cannot combine them, so we're finished. All right, we're going to go ahead and stop there, and we'll pick up on our next video with the next couple examples.